Good morning. This is going to be the first of two videos. The first one is to show the animations, and the second one is going to be to show the math. The second one's going to be the normal edu creations. But I wanted to take a minute and explain what's going on using some animation so that this will make a little bit more sense to you. So far, what we've been doing is spending time looking at the area bounded by curves. Area under a curve bounded by the x-axis, the area between two curves. That's what we've been doing for the last, couple of months and days. Now what we're going to do is look at taking this area and actually rotating it. And if you think about going to Party City, and you can get those table, the centerpieces for the table, and they look flat, but then you unhook them and they rotate open into a three-dimensional figure. Right now what I have is the curve y equals 4 minus x squared. And I'm going to start by revolving this around the x-axis just to show you what happens. So if I revolve this curve around the x-axis, the shape is coming out towards you and continuing down. Actually, I think right now it's actually going to the back first. Yeah, this one's going to the back. So it's going around from the back and then continuing to rotate around, and it's creating this three-dimensional figure that looks, kind of like, think about an M&M. Looks like a big giant M&M, okay? Or a Pac-Man, if you know that Pac-Man guy. But it's going to close up, and then you've taken a two-dimensional figure that has area and created a three-dimensional figure that is a volume. And this section is about how to find those volumes using calculus. What I'm going to do right now is I'm going to change the function. So let me reset it. I'm going to create a new function, and I'm going to use the function, let's see, we're going to use the square root of x. I'm going to use the square root of x. I think I mistyped that. Yes, the square root of x. And this time I'm going to go from 0 to 2. I'm going to set my function. There's my function. And again, I'm going to revolve it around the x-axis. And as it revolves, it's taking out a space, a three-dimensional space. It's cutting out a three-dimensional space, and that three-dimensional space has a volume. Okay? Kind of look at this and say it looks kind of like a little bullet as you rotate it around and complete the figure. And if I switch to, I think this is the solid of revolution, I'm going to switch to the wireframe just so you can see it with a little opening. So now I know this looks hollow, but the idea is not that it's hollow, but that we are taking this three-dimensional shape and creating a solid, and that solid has a volume. Now, this is a really weird shape. We know how to find volumes of prisms and volumes of cones and spheres and cylinders, but what about these very odd shapes? Well, that's where calculus comes into play. Here's another picture of a curve, and if you think about rotating it around, every part of that, every slice of this has a circular shape. The word rotation is important. Now here I'm going to take that square root of x again, and I'm going to rotate it around the x-axis. Here we go. It rotates around. And I'm going to turn this a little bit, and there's that circular shape. Well, imagine if I could take all those circular slices from left to right and add them all up. How do we add in calculus? That's a summation symbol. A summation is how we add things. Sorry, an integration symbol. Ooh, my brain is not working this morning. So if I take all these circles, imagine another way to think about it is like a slice of bread, a loaf of bread. If you have a loaf of bread and cut it into really, really thin slices, each of them will have a surface area. But if you add all the surface areas from left to right, you will get a volume. All right? So this is the visualization of the rotation. Once again, let me reset this from the beginning. Let's clear it all again. Let's do another one. Let's do the graph of sine x. Okay. The graph of sine x looks something like this. And if I revolve it or rotate it around the x-axis, now we can rotate things around the y-axis too. All that's important is drawing a picture and understanding what that rotation looks like. So here it is rotating around the x-axis. Okay, and we get this three-dimensional figure, and we're going to think of all of these little pieces, all the little slices. Again, think of all the little slices as circles, and we are going to use integration to add all the circles starting from left to right. All right, so this is the first part of today's lesson. The second part will be the educations. Okay, hope you're having a good snow day. I'll talk to you soon. Bye-bye.